Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. Today, we discuss the solutions of 4 problems from the section complex numbers, and this is the second part of the 3 parts of the video that is devoted for the complex numbers. Right. This is the question that has appeared in the JEE Main exam held on 29 January 2025 in the first shift. Let modulus of Z1 minus 8 minus 2i less than or equal to 1 and modulus of Z2 minus 2 plus 6i is less than or equal to 2, where Z1, Z2 belongs to the set of complex numbers, then the minimum value of modulus of Z1 minus Z2 is. We are given 4 options. Let's now discuss the solution of the problem in detail. Let S1 be the set consisting of all Z1 belongs to C such that modulus of Z1 minus 8 minus 2i less than or equal to 1. And this is the set of all Z1 belongs to C such that modulus of Z1 minus in brackets 8 plus 2i less than or equal to 1. Right. Let C1 be the set of all Z1 such that modulus of Z1 minus in brackets 8 plus 2i is equal to 1. And what is this? It is a circle with a center at 8 plus 2i and a radius 1. Right. Then what will be S1? S1 consists of all points that lie inside, because it is less than 1, and on the circle C1 because it is equal to 1. So S1 consists of all points that lie inside the circle C1 and on the and points on the circle C1. Right. Now consider let S2 be set of all Z2 belongs to C such that modulus of Z2 minus 2 plus 6i is less than or equal to 2. This is equal to the set of all Z2 belongs to C such that modulus of Z2 is not Z1 minus 2 minus 6i less than or equal to 2. So let C2 be the circle modulus of Z1 minus in brackets 2 minus 6i is equal to 2. It is a circle with the center at 2 minus 6i and a radius R2 is equal to 2. The center of C1 is A, we said 8 plus 2i. The radius of C1 R1 we said 1. And in this the center of C2 is B, we have denoted 2 minus 6i, and the radius R2 is equal to 2. Then what will be S2? S2 consists of all points that lie inside and on the circle C2. Right. Now, what is that we want to find? The minimum of modulus of Z1 minus Z2, where Z1 comes from S1 and Z2 comes from S2. Z1 consists of infinitely many points and Z2 consists of infinitely many points, and for each point of S1 and for each point of S2, we have to find modulus of Z1 minus Z2. So we get what is the modulus of Z1 minus Z2? That is the distance between Z1 and Z2. How many distances you will get? Infinitely many. For all of them, you have to consider the minimum. That is the concept. But how do we get? So now, look at the diagram, what we have. So this is the circle C1 and this is the circle C2. And points that lie inside and on C1 is in S1, and in S2 all points that lie inside and on C2 in S2. So Z1 from S1, Z2 from S2, the distances you have to take and the minimum of all of them. That will be this distance. This distance. What is this distance? The distance means smallest distance is this distance between their radii, their centers, minus this radius and this radius, minus R1 and R2. That will be the minimum distance, minimum distance of Z1 and Z2. So Z1 coming from S1, Z2 coming from S2, the minimum distance is the dotted one, and that is equal to the distance between A to B, A is 8, 2 and B is 2, minus 6, minus R1 minus R2. Minus R1 is minus 1 minus 2. What is the distance between 8, 2 and 2, minus 6? Distance formula used under the square root of 8 minus 2 whole square plus 2 minus minus 6 whole square, and that is minus 1 minus 2, that is equal to, this is 8 minus 2, 6 square plus 8 square, that is 10, 100, under the square root of 100, that is 10 minus 3, that is equal to 7. So where is our answer? Where is our answer? The minimum value of modulus of Z1 minus Z2 is 7, and that appears against option 3. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of this problem. Let's move to the next question. Right. This question has appeared in the JEE Main exam held on 28th January 2025 in the second shift. The given problem is if alpha plus I beta and gamma plus I delta are the roots of x square minus in brackets 3 minus 2i multiplied by x minus in brackets 2i minus 2 is equal to 0, where I is the imaginary unit that is under the square root of minus 1. Then alpha, gamma plus beta delta is equal to, we are given 4 options. Let's now discuss the solution of the problem in detail. The roots of the given quadratic equation, this equation x square minus in brackets 3 minus 2i into x plus 2 minus 2i, right, are given by x is equal to minus b is a quadratic equation plus or minus under the square root of b square minus 4ac by 2a. A is 1, b is minus of in brackets 3 minus 2i, and c is 2 minus 2i. Substitute in this and simplify. You will get minus 3 plus 2i plus or minus under the square root of minus 3 minus 4i whole by 2. Now, how to find the square root of a complex number? Recall that what we have studied in our lower classes, the square root of a plus ib is equal to plus or minus in brackets under the square root of mod of a plus ib plus a whole by 2 plus b by mod b times I under the square root of mod of I plus a plus ib minus a by 2. Now a is minus 3, b is minus 4. Substitute in this. Right. We have substituted. And this is equal to plus or minus modulus of minus 3 minus 4i is 5 under the square root of 25 is 5. 5 minus 3 by 2. This is minus 1i into under the square root of 5 plus 3 by 2. And this is plus or minus 1 minus 2i. And one root is 1 minus 2i and the other root is minus 1 plus 2i. Let's take this 1 minus 2i and substitute here. So that is equal to minus 3 plus 2i plus or minus 1 minus 2i by 2. One time we take plus, the other time we take minus and simplify. Then you will get the first one is minus 1 plus 0i. The second one is minus 2 plus 2i. Right. So thus we got one is alpha plus I beta and the other is gamma plus I delta. So given alpha plus I beta and gamma plus I delta are the roots of the given equation. Therefore alpha plus I beta is minus 1 plus 0i and gamma plus I delta is minus 2 plus 2i. So this will imply alpha is minus 1 and beta is 0, gamma is minus 2, delta is 2. What we want is alpha gamma plus beta delta. Alpha is minus 1 into gamma is minus 2 plus beta delta. Beta is 0 into delta is 2. Multiply, simplify, we will get 2. So thus we get alpha gamma plus beta delta is 2. So the answer to this question is option 4. That is the detailed discussion of the solution of this problem. Let's move to the next question. Right. This is the question that has appeared in the JEE Main exam held in 28th January 2025 in the first shift. Let O be the origin. The point A be the complex number Z1 given by root 3 plus 2 root 2i. The point B is the complex number Z2 be such that root 3 times mod Z2 is equal to mod Z1. And it is given argument of Z2 is equal to argument of Z1 plus pi by 6. Then we are given 4 options. Option 1 says the area of the triangle ABO is 11 by root 3. Option 2, ABO is an obtuse angled isosceles triangle. Option 3, ABO is a scalene triangle. Option 4, area of the triangle ABO is 11 by 4. Let's now discuss the solution of the problem in detail. We have O, the origin in the Argand plane. The complex number corresponding to A and B are Z1 is equal to root 3 plus 2 root 2i, that of A, and that of B is Z2 respectively. Thus we have the triangle ABO and OA, the complex number corresponding to A is Z1. The OA will be modulus of Z1, that is modulus of root 3 plus 2 root 2i, and that is under the square root of 3 plus I, root 3 square plus 2 root 2 square under the square root of, that is root of under the square root of 11 OA, that is the distance of one of the sides. That means the one side OA of the triangle ABO is of length root 11. Given root 3 times mod Z2 is equal to mod Z1, and that is equal to mod Z2 by mod Z1 is 1 by root 3. That is same as modulus of Z2 by Z1. Modulus of Z2 by Z1 is 1 by root 3. Now from here, mod Z2 is equal to 1 by root 3 into mod Z1, and 1 by root 3 into mod Z1 is root 11. That is under the square root of root of 11 by 3. Mod Z2 is the side, the length of the side OB is root of 11 by 3. Thus we got two sides of the triangle OAB, and they are not equal. They are not equal. Right. Now let's move to the next slide. Right. We are given argument of Z2 is equal to argument of Z1 is equal to pi by 6 plus pi by 6. Argument of Z2 is equal to argument of Z1 plus pi by 6. Then argument of Z2 minus argument of Z1 is pi by 6. And you know the argument of A minus argument of B is argument of A by B. That is argument of Z2 by Z1 is pi by 6. Right. Right. Then we can calculate what is Z2 by Z1. Now Z2 by Z1 is modulus of Z2 by Z1 into e power I times the argument of Z2 by Z1. You see, in the polar form, Z is equal to mod Z into e to the power of I theta, where theta is the argument of Z. That's what we have used here. So this is Z2 by Z1. Modulus of Z2 by Z1 from here, it is 1 by root 3 into e to the power of I pi by 6. And that will Z2 by Z1 is equal to 1 by root 3 into e to the power of I pi by 6 is cos pi by 6 plus I sin pi by 6. And we have put the values of cos pi by 6 is root 3 by 2. I sin pi by 6 is 1 by root 2. And that is root 3 plus I by 2. And there is a 1 by root 3 already. So root 3 plus I by 2 root 3. This is Z2 by Z1. So what is the AB? The distance AB. A is represented by Z1, B is represented by Z2. Therefore, the distance AB, the length of the side AB is modulus of Z2 minus Z1. This can be modulus of Z2 by Z1 minus 1 into mod Z1. Mod Z1 cancels and you will get mod Z2 minus Z1. And that is equal to modulus of Z2 by Z1 is root 3 plus I by 2 root 3 minus 1 into under the square root of 11, because modulus of Z1 is root 11. And now simplify, and 1 by 2 root 3 we have taken common, taken the LCM, then we got this one root 3 plus I minus 2 root 3 after taking the LCM into root 11. Now this is 1 by 2 root 3 into root 3 minus 2 root 3 is minus root 3 plus I modulus into root of 11. Take the modulus 1 by 2 root 3. The modulus of this is under the square root of 3 plus 1 into root 11. This is 1 by 2 root 3 into root of 3 plus 1, 4. Root of 4 is 2. 1 by 2 root 3 into 2 is 1 by root 3. 1 by root 3 into root 11 by 3. That is modulus of Z2 is OB. Right? We got this. So thus we got the length of the side OB, OA is root 11, OB is root of 11 by 3. The length of AB is root of 11 by 3 and that is equal to OB. AB is equal to OB. So that means your triangle ABO is an isosceles triangle. Look at the options. There is only one option which talks about isosceles triangle. That is the option 2. That is ABO is an isosceles triangle. There is an adjective is there, obtuse angled. But anyway, there is only one triangle, which is an isosceles triangle. Therefore, I immediately say my answer to this question is option 2. But now I will explain to you how this obtuse angled triangle is coming now. So for that, let's look at the diagram. The triangle ABO, A is represented by Z1, B is represented by Z2, O is the origin. ABO is a triangle. Now you see, angle BOA is argument of Z2 minus argument of Z1. How? Argument of Z2 means the angle that this OB makes with the x-axis, and argument of Z1 is the angle that this line OA makes with the x-axis. Minus of it is this one, BOA is pi by 6. But now we have seen AB is equal to OB. Therefore, the opposite sides are equal. Opposite sides are equal. Angle BOA is equal to angle BAO, each is pi by 6. It's an isosceles triangle. Right. So then what will be, this is pi by 6, this is pi by 6. What will be this one? That is pi by 6 minus pi by 6. And therefore angle OBA will be 2 pi by 3. What is 2 pi by 3? It's obtuse angle. So ABO is an obtuse angled isosceles triangle, and that is the answer is option 2. That is the detailed discussion of this question. And it is an interesting question. We'll move to the next slide. Right. This is the question that has appeared in the JEE Main exam held on 24 January 2025 in the first shift. If alpha and beta are the roots of the equation 2z square minus 3z minus 2i is equal to 0, where I is the imaginary unit under the square root of minus 1, then 16 times the real part of alpha to the power of 19 plus beta to the power of 19 plus alpha to the power of 11 plus beta to the power of 11 whole by alpha to the power of 15 plus beta to the power of 15 multiplied by the imaginary unit of the same thing what is here is equal to. We are given 4 options. And the question is looking very terrible, but the answer is simple. Let's now discuss the solution of the problem in detail. We first take alpha to the power of 19 plus beta to the power of 19 plus alpha to the power of 11 plus beta to the power of 11 whole by alpha to the power of 15 plus beta to the power of 15 is equal to. Take alpha to the power of 19, alpha to the power of 11, take alpha to the power of 15 common. Then it will be multiplied by alpha to the power of 4 plus beta plus 1 by alpha to the power of 4 plus beta to the power of 15 in brackets beta to the power of 4 plus 1 by beta to the power of 4 by whole by alpha to the power of 15 plus beta to the power of 15. Agreed. That means take alpha and try to get alpha to the power of 4 plus 1 by alpha to the power of 4. Similarly, beta to the power of 4 plus 1 by beta to the power of 4. For that, given alpha is a root of this quadratic equation, therefore alpha satisfies this quadratic equation. That means now multiply throughout by alpha. Then it will be 2 alpha minus 3 minus 2i by alpha is equal to 0. 2 times alpha minus I by alpha is 3. That means alpha minus I by alpha is 3 by 2. Take that, square it. Alpha minus I by alpha is 3 by 2. Square it. Alpha square minus 1 by alpha square, because I square is minus 1, minus 2i. 2 alpha into I by alpha, alpha cancels, minus 2i is equal to 9 by 4. We got alpha square minus 1 by alpha square is equal to 9 by 4 plus 2i. Again square it. Take that and again square it. Then you will get alpha to the power of 4 plus 1 by alpha to the power of 4 minus 2 into alpha square into 1 by alpha square, that is minus 2, into 9 by 4 whole square, 81 by 16, plus 2i whole square minus 4. 2 into 9 by 4 into 2i is 9i. Simplify, we will get alpha to the power of 4 plus 1 by alpha to the power of 4 is 81 by 16 minus 2, because you have brought minus 2 to the other side. You will get minus 4 plus 2, that is minus 2 plus 9i. Thus we got, after simplification, 49 by 16 plus 9i. In a similar fashion, you will get beta also. The beta also, you will get beta to the power of 4 plus 1 by beta to the power of 4, the same answer, because beta is a root of that one, same steps you will get it. We continue in the next slide. Right, that's what we have. Now alpha to the power of 19 plus this one I have written. This is what I have written. Now in this, alpha to the power of 4 plus 1 by alpha to the power of 4 and beta to the power of 4 plus 1 by beta to the power of 4, they are equal. They are equal. So that is equal to alpha to the power of 15 plus beta to the power of 15 into alpha to the power of 4 plus 1 by alpha to the power of 4 by alpha to the power of 15 plus beta to the power of 15, because they are equal. Now, they are equal. Now, alpha to the power of 15 plus beta to the power of 15 cancels both numerator and denominator, and we get alpha to the power of 4 plus 1 by alpha to the power of 4. That is 49 by 16 plus 9i. Now, we are ready to compute 16 times real part of the whole thing into the imaginary part of the whole thing is 16 times the real part of this whole thing is 49 by 16 plus 9i into the imaginary part of this whole thing is 49 by 16 plus 9i. And what is the real part of 49 by 16 plus 9i? 49 by 16. The imaginary part of 49 by 16 plus 9i is 9. So it will be 16 times 49 by 16 into 9. 16 cancels and you will get 49 into 9. That is 441. Where is the answer? So the answer appears against option 1. That is the detailed discussion of the solution of this problem. This problem is also an interesting problem. Right. In this video, I have discussed 4 questions and their solutions from the section complex analysis, and definitely 2 questions are very interesting. All of them are good questions. Right. I am sure that you have understood the solutions of these problems. Thank you for watching my video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am sure we will be meeting once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.